Think about maybe some of the things you learned in the last unit, like representing functions a bunch of different ways. You can represent a function, and so we're focused on linear functions here, right? The big focus on this is linear functions. Oh, I know what my problem is. There it is. We're focused on linear functions here in this particular chapter. You look more at functions in general and domain and range and all that stuff, but you're focused specifically on linear functions, looking at equations of linear functions and graphs of linear functions and tables. Basically, you need to kind of look for the connection between those different forms, right? There's lots of different forms, not forms. It's hard to write and talk at the same time. I was about to write the word worms, but forms, a bunch of different worms. Different forms of this. You have words. I know what my problem was. I was going to write words and forms together, and I was going to end up writing worms. Words, graph, table, equation. Basically, these different forms of writing a linear function. Okay, something that's a straight line function. Probably you're going to start with this, and then try and come up with the other ones from it, or this and come up with the other ones from it. In grade 8, you, in theory, learned these, how to decide if something, I mean, obviously from a graph, it's pretty obvious whether something's a straight line function or not. If I just create a graph and draw a straight line, then it's a linear function, right? If I was to go from there and let's say go like this, or like this, or wherever, right? As long as that thing's a straight line, where can I stop? Right there. That's a linear function, right? You could even have a table for that, right? In grade 8, you looked at, from a table, how to decide if something was a linear function. If you have a table, x and y, and the points in there were 0, 1, 1, 3, 2, 5, 3, 7. In grade 8, you learned that if it's a linear function, these jumps are consistent here, right? And we looked at that again in the last unit too. If that changes 1, then this has to be constant. If the change is constant over here, this is delta x, change in x, then this has to be constant, delta y, right? This is 2 plus 2 each time. Plus 1 plus 2, right? If I jump this up 3, then it went up to 6, right? If I did 3 here, proportionally, if 1 over here is 2 over there, 3 over here has got to be how much over here? What kind of change has got to be here? What kind of change has to be there? Right? If this is twice as much, the change in y is twice as much as the change in x. Right? The change in y, twice as much as the change in x. So if this is 3, this has got to be what? 6, right? It's got to be 6. If you extended the graph, it'd be like skipping a couple points, right? This is 1 over there, 2 up here. You learned how to calculate the slope. Basically, the slope from a table is looking at that, right? Looking at what the change is there. 2 compared to 1, or 6 compared to 3. If you put this on here, it would be going 3 over there, 6 up here, and that point would be on the line as well. Okay? So hopefully we're good at going from table to graph and back and forth and being able to decide if something's a linear function. But this is the big one that you haven't spent much time on, writing an equation for this. This thing has an equation that's like this, 2x plus 1. So you're going to look at writing an equation and writing it in a bunch of different forms. You're going to look at writing it in that form. You're going to look at it in writing this form, 2x minus y equals negative 1. And you're going to look at writing it in other forms too, like y equals 2x minus 1 plus 3. Okay, there's a bunch of different forms of the same thing. All of those equations give you the location of that line. So that's the big focus in this unit here. Okay, and then of course words. Done that before. So the first activity you have to do here is using a situation to create a graph and a table, and then try and write some equations for that, or write an equation for that. Okay, so if you look at the first activity to do in here, gives you a situation. It just says something simple like something continuous Large container currently has 1 liter of water and is being filled at a constant rate of 1.5 liters per minute. So you're going to create a graph, decide whether you join the points or not. Does the line slope up or down? You're going to put some of the values in that table, and then you're going to try and think about writing an equation for that. Okay? Down here it says, how can you write an equation for some lines? I don't know if I actually put the question here that I want you to write an equation, but I do want you to try and write it all 3 ways. I did. Graph, table, and equation. So create the graph, create the table, and then try and write the equation between A and T. Writing an equation means you're going to have something like A as a function of T, something A as a function of T. So you're going to try and write an equation for that. You might have to work together. You might have to try and think and just check that it works with the points that you have. Okay, and then you have a different, similar situation but slightly different. And then some of these things you can discuss what they mean. What does the x-intercept mean? What does the y-intercept mean? What does the slope represent in the situation? And then you might have to, if you're still not sure what this means, have a look at it in the textbook. It talks about it in the first section. Okay, and we're going to talk more about this later. Okay, slope-intercept form. But you can get that term in the textbook, and then you can start working on the examples. Okay, remember that these are in the textbook for you to follow. Okay, so can we get going on that, please? Maybe don't take more than, 15 minutes for these first two things. And work together with somebody unless you just don't like the person next to you, or unless you really want to work by yourself. I would say, while you're discussing, you're going to hopefully get something out of it, okay?
Fair enough.